Hello, good day. Today I'll be discussing how a three-phase motor controller works and a little bit about switching. This is a very basic video on how to do this, so I wouldn't recommend putting this in an actual solution, but if you just want to get a brushless motor spinning, like a BLDC or maybe a three-phase AC induction motor, this will get you on the right track because a lot of the videos on the internet are a little bit too much, they overcomplicate everything. So this is a little brushless motor I got off eBay, and we've got an Arduino here. We've got some BJTs running in an inverting amplifying scheme. I think it's triode. Yeah, I think it would be triode for digital, or if it was MOSFET, it would be saturation. We've got 6 MOSFETs in the motor, and so yeah, first I'll show you this thing turned on. There we go. Yeah, it's vibrating off the book, but alright, that's enough of that. So yeah, here's the circuit. The way it works is you've got your power switching solution, so you've got 6 MOSFETs right over here, and we've got 6 BJTs, and they're running an inverting scheme. So the way this inverting scheme works is that from the Arduino a signal will be received, and it goes into it, and so if it receives a high signal, it'll output a low, etc., etc. The reason I have this is not that I necessarily want to invert the controls, but because I want a way to switch on and off higher voltages than the Arduino can output. Because Arduino's output pins, I think they're like 3.3 volts, and I would like 5 volts for switching on and off MOSFETs. But you can adjust this as you need. It doesn't matter if it's running an inverting scheme, the motor will spin just fine. I think you just have to keep in mind, I'm pretty sure the motor would spin in the opposite direction than what you would want with the switching scheme I'm using. So yeah, you would have a DC input and then 3-phase AC output. And so let's go over to the switching scheme. And we've got this over here. So the way it works is that it starts off with pin 1 on and pin 4 off. As you can see, they're in series, and so ignore that it's high. Well, just pretend that pin 1 is high and pin 4 is off. That's how we start off until we get somewhere like 3.33 millisecond mark. You're going to turn on MOSFET 2 and turn off MOSFET 5, and then we're going to get to the 5-second mark, and then you're going to turn off pin 1 of the Arduino and turn on pin 4 of the Arduino. And so yeah, we jump up to high, and then we're gonna, so at the 6.66 millisecond mark, you're going to turn on pin 3 of the Arduino and turn off pin 6, and then at the 8.33 millisecond mark, you're going to turn off pin 2 and turn on pin 5. And then at the 11.66 millisecond mark, you're going to turn off pin 3 and turn on pin 6. And so what this is doing is it's cycling between the motor phases. Overall, this is a very terrible way of getting the motor to spin. I think this is like a 50% modulation scheme or something. I forgot the name. But this is really bad, and it'll heat up your motor and it'll heat up the MOSFETs. What I would recommend is that you try to figure out how a sine triangle modulation scheme works for switching, and you can implement that. You'll get the motor spinning smoother. And the way variable frequency drives work is that they're very similar to this, only a VFD is going to change the frequency of the timing. Usually they're a lot smoother. They'll have, probably instead of MOSFETs, in a big industrial application, you'd be using an IGBT, integrated gate bipolar transistor. IGBTs have some sort of internal capacitance. You got to deal with that. I'm not sure if you need like a pull down resistor or something, but you would be able to replace the MOSFETs with that, to my understanding. So if you want to drive a ginormous AC induction motor, that's what you would do. Yeah, as far as how the motor operates and how you can improve this, if you can increase the voltage provided by a power supply, you get the motor spinning faster. But it would also spin faster if you shorten the duty cycle, or shorten the on time of the transistors. Now, shortening the on time only works up to some point, because eventually the motor will need a higher voltage in order to spin faster. That's why you see the kV ratings on these BLDC motors. Another limitation is that this switching scheme draws an incredible amount of current into the motor at the peaks, so you'll need some sort of power supply that can handle that. My issue here is I only have a 5 volt 2 amp power source, so the motor can't spin that fast. But I mean, you can play around with this and see how you can get this working. Please leave a comment or something if you found this informative. I'm just making this as entertainment purpose. I don't suggest you implement this in application, and always be careful with electricity, especially with high voltage sources. Maybe in like an industrial application, you've got something huge going on. And the main issue with this is that these MOSFETs heat up a lot because it's like a square wave modulation, and there's no heat sinks on it. The motor also gets quite hot, but I think you can run it for a good amount of time. Anyways, that's it for now. Thank you for watching, and if you'd like, subscribe. Take care.